The question says which of the following is the correct order of dipole moment. You can see three compounds are given there, and in all these three compounds benzene, 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 but the groups which are attached to the benzene, they are in the same position with respect to each other. Okay, you can see respect to carbons are there. Okay, we have learned dipole moment is directly proportional to electronegativity difference. Higher the electronegativity difference between the atom, higher is the dipole moment. Okay, let me write it. Dipole moment increases as the electronegativity difference increases. Remember. Okay, so you can see methyl group is nothing but it is CH3 only. We have CH3. If I mention in this place, it is CH3 there. Here also carbon is there. Here also carbon. It is also CH3 is there. I can write carbon, carbon is there. Carbon, carbon. Okay, carbon, carbon. So there is no electronegativity difference. Okay, so dipole moment will almost be nil. But one thing you can keep in mind: this methyl group is acting as a positive inductive group. It is considered as electron donating group. Then it will be donating electron density like this. If we consider its property, so it is acting as a positive inductive group. It has capacity of donating electron density. Since the flow of electron density is taking place from this group towards benzene, so we can show the arrow mark, means the side of electron density is going that side. We show the arrow mark in the form of, in terms of dipole moment. Okay, slight dipole moment will be there if we consider the positive inductive effect. Okay, now we have Cl, Cl. This carbon is there, carbon is there. Cl is more electronegative than carbon. It is pulling electron density. Dipole moment is there. Okay, but halogens are also considered as a plus M group because they are having lone pair. How many lone pairs are there? 3 lone pair. Each Cl is having 3 lone pair because it is forming one single bond. Okay, so they are considered as minus I group, tendency to pull the electron density, and so they have also tendency to donate electron density because they are having 3 lone pairs, so they can donate electron density also. Overall, we need to focus on the electronegativity difference. If I am talking about carbon and Cl is there, what is the electronegativity difference? Okay, and in this case, this is carbon in there, this is carbon. So in this case, we have carbon, nitrogen, and this is carbon, oxygen is there. If we talk about, we have electronegativity of these elements. So we have nitrogen, this is carbon, this is oxygen, and this is fluorine, and this is Cl is there. So you can see they are present in the second period and the Cl is present in the third period. Smaller the size, higher the electronegativity. Okay, they can see nitrogen and oxygen. Here we have very high electronegativity. Dipole moment will also be very high because dipole moment is directly proportional to electronegativity difference. Higher the electronegativity difference, higher the dipole moment. So you can see nitrogen and hydrogen are given here. Nitrogen as well as hydrogen. So carbon, nitrogen, carbon, oxygen, higher electronegativity difference is there. Then dipole moment for this compound will be very high. After this we have Cl, Cl. Carbon, Cl, carbon, Cl. Here also electronegativity difference is there. Electronegativity difference. In this case, carbon, 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 least electronegativity difference. If we consider this as a positive inductive group, it is donating electron density, but that much it will not be there. It will be generating a strong dipole moment. Okay, it has very high dipole moment based on electronegativity difference. Then we have second one, and the least one is what? Third one. So we have first, then second, and it is what? Third is there. First, second, third. You can see option A is correct. If you like this video, please share and subscribe to the channel.